On April 11, 2016, the students and some members of the faculty of the first senior high school of Kilkis that are participating in the program Erasmus eLearning by Nature visited the region of Lake Kerkini. One of the students' activities was to study the quality of the lake water. Lakes are generally more vulnerable to pollution than rivers. Due to the absence of currents in lakes, permeability of light and temperature are important parameters. The temperature acts upon the function of an organism that lives in the lake as well as its reproduction. The temperature varies from spot to spot of the lake. It is determined by the depth and depends on the season and the time of the day. Also, it depends on how people use the land in the vicinity of the lake. When our team visited Lake Kerkini on 11 April 2016 during noon while the weather was mild, the temperature of the lake in a distance of 5 centimeters from the surface of the water was 2 degrees Celsius. Other chemical parameters influencing the lacustrine systems are the concentration of dissolved oxygen, nutrients, and active acidity. More specifically, the lake's oxygen enrichment occurs through diffusion of atmospheric oxygen in the water and through the oxygen producing during photosynthesis by aquatic plants, algae, phytoplankton, and periphyton. In lakes, oxygen exists in many forms and is not always dissolved in water. The solubility of oxygen and the distribution of the lake water depend on the atmosphere, the water temperature and the thermal stratification of the lake, the altitude, atmospheric pressure, the rippling, the presence of photosynthetic organisms, the presence of aerobic organisms, the organic and inorganic material produced within the lake or entering the lake, the oxygen content of the incoming in water lake, epolymious sources, surface currents resulting in the lake, and finally the shape and size of the basin. Of the nutrients that determine biodiversity in an ecosystem, nitrate, nitrite, and ammonium are compounds of nitrogen which enter the water from freezing atmospheric nitrogen, the corrosion and leaching of soils of the catchment, from underground and surface waters, decomposing organic material from bacteria, and from all kinds of waste flowing into the lake, agriculture, and municipal wastewater. The ammonium and nitrite salts enter the water, and when there is enough oxygen, the bacteria convert it into nitrates, bacterial nitrification, which are absorbed by vegetable organisms. One of the main nutrients of animal and plant organisms is phosphorus in the form of phosphate ion in particular. Sources of phosphates in the aquatic environment are agricultural and industrial effluents, and their liberation is achieved through soil erosion in the catchment area. Phosphorus is often a limiting factor of primary production in inland waters and is crucial to the restoration of the ecological balance. The concentration of phosphorus in aquatic environment depends on the temperature, the pH, and the concentration of nitrates and nitrites. The large supply of nutrients causing growth of algae in natural waters is called eutrophication. Eutrophication results in the decrease of dissolved oxygen, and anaerobic conditions prevailed with release of stench, creating toxic compounds and necrosis of the aqueous bioeconosis. Eutrophication is a natural phenomenon. However, the influx of nutrients in natural waters by human activities accelerate the natural phenomenon at a terrifying speed. Another factor that characterizes the water quality and affects nitrification is active acidity. Natural waters have pH values ranging between 4 to 9 units, while prices 6.5 to 8.5 is in most cases the most suitable for aquatic organisms. The acidity of water plays a vital role in the development of aquatic organisms as it affects the water content in minerals. Changes in acidity of water can increase soil erosion by water and consequently enrich water with ingredients that were trapped in the soil. Students' measurement of nitrate was 0.1 milligram per liter when normal values are below 50 milligrams per liter. For phosphate, 0.5 milligram per liter with normal values below 0.7 milligram per liter, and the active acidity 7.5 to 8. The above prices for the lake indicate that Kerkini is a mesotrophic lake with controlled influx of nutrients, effluents and use of fertilizers, resulting in a dynamic equilibrium of species.